Hello and welcome to the Virtual Engineering Centre podcast, Engineering in Digital. I'm Emma Green and today we're going to be talking about the Internet of Things, or better known as IoT. We use this technology more and more in our everyday lives as devices are becoming increasingly connected. Back in 2016, Cambridge consultants believed there were 13 million IoT devices being used within the UK, with an anticipated growth of 156 million devices by 2024, improving connectivity, communication and convenience. In this podcast, we will be talking with the experts to find out exactly what IoT is, and we're joined by SMEs and friends of the Virtual Engineering Centre to highlight real business applications of this technology and how IoT can enhance your business processes and customer expectations. So our first guest is Thomas Kendall, who's the Virtual Engineering Centre Project Engineer and IoT Specialist. So welcome, Tom, and thank you very much for joining us today. So if you'd like to just introduce yourself, a bit about your background and expertise and what you do at the Virtual Engineering Centre.
Yeah, great. So I am a project engineer at the VEC. I suppose my job title is IoT Specialist, which will be why I'm on this episode of the podcast. My background isn't particularly sensory or software based. I was a mechanical engineer through degree, and my earlier work experiences mainly focusing on manufacturing systems and designing manufacturing equipment, but it was through doing my PhD and getting involved with a lot of Industry 4 related projects and kind of supervising students and entering competitions that I kind of became a bit obsessed with IoT side of things as well. It kind of all came from when designing some manufacturing equipment and considering where the industry is moving, that actually you need to be designing equipment and machinery that can communicate with other machines. That actually we can't design machines like they were 20 years ago that are standalone. They need to be able to communicate, and it all stemmed from that and ended up here at the VEC doing IoT stuff, which is great.
Perfect. So what type of equipment and manufacturing systems were you helping to design?
So I suppose you would call them semi-traditional or non-traditional manufacturing or machining specifically. So I worked on electrochemical machining, or a form of which, if people don't know, is basically removing metal with salt water and electricity, is the basics of it. So kind of designing a new version of that to be used predominantly for post-processing metal 3D printed parts, amongst other things for biomedical and electronics, things like that.
So it's interesting as well that you've said that kind of like in your career and studies that you've also seen shifts already from, like you said, traditional manufacturing to then the need for this type of technology and different equipment as well. So in your own words, how would you best describe IoT, or industrial Internet of Things, and how did you select this route as part of your career?
To me, IoT, or Internet of Things, is just this massive network of devices that can communicate with each other. Put simply, that's all it is. You have things all over the place, so then there's the things in IoT that can talk to each other, and actually it's about linking those up and transferring data from one device to another, and actually how you use that data to do things that you couldn't do before. This ended up as part of my career, I think, just through opportunity was one of them. That actually working for a university, and working at universities, you're on the front edge of what's happening in industry. So, and as you said before, Emma, you kind of, even over the short time period that I've been working in it, things have changed so much. And like when we first started doing it like 8 years ago, what you were able to do then, or how easily you could do something, is like much easier now. For example, or you can do things that you couldn't do 8 years ago. So we kind of stumbled into it almost, of having it on the side of going, okay, we're doing engineering and manufacturing, but actually we need sensors and devices and cloud and communication stuff, and how do we get those to work together. And then through that I was just learning it and practicing it and putting it into the things that I was designing, and yeah, kind of kept going. So it became more IoT than manufacturing in the end.
Yeah. Well, I suppose it's quite interesting because obviously at the VEC we work with a lot of manufacturers overall with projects and ERDF projects and things, but I suppose it's quite interesting as well to see how IoT is becoming a lot more predominant within a lot of different projects as well, not just manufacturing, how other industries are using these technologies for a lot of their own projects. So as IoT is all about connectivity, let's talk about sensors. So how does IoT best use sensors, and what are the ways businesses can use these small devices for big impact?
Yeah, so IoT and the wider Industry 4 context is all centered around data, and the data has to be produced by something. And the vast majority of time, those are sensors. And I mean, sensors are nothing new. We've had them for decades, all around us in a lot of things that we own. It's just how we're using the sensors that are different. In a lot of cases, those sensors are sensors that may already exist on a machine that have been there for 10 years, but actually weren't doing anything to communicate with a wider context. So actually IoT is about not only installing new sensors, but how we use sensors that are currently in industry, and how do we get those to communicate and get data out of. And actually IoT uses sensors just for that reason. That's why IoT is really important, of not just having sensors but gaining valuable insight out of them. So actually it's all about, number one, getting the data, but number two, doing something important with the data, and that all comes from the sensors. There's a lot of ways that businesses can use them for big impact. Kind of, the sky's the limit almost in ideas for what you can use sensors for. Like there's some things that are perhaps more traditional now, of maintenance or quality control, or just general machine monitoring, wanting to know what's going on inside your production system or inside your machine, or helping automation, but actually it could be much more niche things. That actually you just have to stop and think as a company, what data could be really useful for us? What don't we know that's holding us back? And actually maybe it's, I need to know an air temperature in this thing, that would be really useful. Or I need to know if this door's open, or we're losing heat and we need to save energy. Could we monitor how much energy something's producing, or how much heat we're losing for something? And that means we could be more green, or we could save money. So it's thinking outside the box of going, okay, traditionally sensors measure temperature and pressure and vibration or speed or whatever you want, but actually you can probably find a sensor to fit anything that you want to know. So for every company that's different, but sensors just mean you can get that data that at your fingertips that you wouldn't otherwise have.
That's interesting. Have you met many companies and businesses previously where maybe they were collecting data that they might not have realised that they had access to, like they didn't realise that certain machinery or devices actually collected data that they just weren't accessing or using previously?
Yeah, and it's kind of an issue that comes up quite a lot. Perhaps companies buying rather expensive equipment that does monitor a lot of things and store a lot of its own data, but they don't have access to it, or perhaps they have access to it on the machine, on the screen, but they can't get the data out of it. So they know the data's there and they want to see the data, but actually it's how do you get the data from the machine and the sensors that are on our very nice expensive piece of equipment, and get there somewhere that we can use them. So yeah, in that case, it comes up a lot of people knowing the data's there, but they don't know how to grab it almost, and how to use it. But then, even things like our phones or cameras around the place, or collecting data. That maybe companies don't consider and think, oh, maybe we could use some of that data from our cameras or, our phones or GPS or things that are already collecting information, but they're not using.
Yeah, that's it, isn't it? Like data and sensors, without many people even realizing it, are so central to everyday life nowadays. Like even your phones, your smartphones collect so much data on you. Your shopping, for example, if you use like a Tesco club card, you scan it, that's data. But it's how, obviously, it's how, like you said, it's not just having the data, it's then being able to use it for better use and for business benefits. So that's really interesting. So sensors obviously have access to and share with the business a lot of the data we just discussed. But where is this normally stored? I know you just said then it's like sometimes it can be stuck on a machine, as it were. But does this lead to further investment for storage, for example?
So it can do. So it all comes down to what your use case is as a company. And what you need in terms of storing data is very much dependent on your use case. So, for example, if I just wanted to measure the temperature in this room once an hour for a day, it's not going to produce very much data at all. But if I wanted to measure the vibration in my car engine, I'm going to have millions of data points a day, which requires a lot different infrastructure. So it all comes with, actually, it doesn't have to, is the answer. You can have a memory card, you can store things on devices and locally. You can go one step further and store your data locally in a wider company context, perhaps on servers that are local, or if you need quite a lot of storage, then either you need big local servers or you can use cloud. So it really depends. People quite often link, okay, well, we get data goes to cloud, and I think that's kind of the modern thinking of it, but it's not necessarily true. It's about getting data to the point where it's useful. So actually, IoT, and especially machine-to-machine communication area of that, is I just need my machine to my left to speak to my machine to my right. So actually the data doesn't need storing at all. It could just be sent from one to the other, and it doesn't need to be stored locally or in the cloud or anything like that. So in some cases it doesn't need to be stored full stop. But it really just depends. It can be something so small, or it could be massive cloud, everything in between.
Yeah, like you said, it's purely dependent on the case itself and the business itself, I guess, and their needs. So staying on the topic of like networking in the cloud, many of us would have heard of the cloud, like you mentioned, and everyday uses may include storing, for example, phone photos and videos. So if you drop your iPhone, your iPad will still have all these images, for example. So how are businesses using the cloud?
So there's a lot of ways in which businesses can use the cloud, not just for data storage. So I know in your example there, we kind of think of clouds for storing photos or movies or files, thinking Dropbox and Google Cloud and everything like that. And it can be that. It can be storing data on cloud, offsite. I mean, there's a lot of benefits to that. So when we're thinking about storing data and transporting data, that can become very expensive for a business. So you can set up your servers and your networks, but then you need somebody to look after it and update it, and it's all your responsibility. And you've got to think about security quite a lot if it's your own. So clouds give an opportunity, especially for smaller businesses, or perhaps not like super digitally technology thinking businesses. That's a terrible way of putting that, but businesses who maybe don't have a lot of experience of digital technology kind of takes out that issue, so they can store a lot of data securely in a location that they don't have to look after and have access to from anywhere. So that's, I suppose, point two, is cloud gives you these opportunities to access data from anywhere or from nowhere. So if you're wanting to do something with your data and it was stored locally, then you have to do something with that data locally, writing programs on local machines. What the cloud does, it gives access to data all over the world. So you could look at your data sat from a different country. You could monitor your machine sat anywhere you wanted to, as long as you had an internet connection. But actually, these cloud platforms now have so much computing power that it allows companies to do what they wouldn't be able to do themselves. So when we have millions and millions of pieces of data and we want to look through that, perhaps want to do some machine learning and data analytics, and to do that locally, we require some really serious hardware. But being able to write those programs and run them remotely on the cloud automatically, where you don't have to worry about your computers or anything else, just means that companies can take advantage of a lot of software and a lot of processing power that they wouldn't otherwise have access to. And the cloud kind of allows that. And we see a lot more things moving to cloud. So software moving to cloud, you can even write on Microsoft Office without having it installed on your computer or whatever else. But that also goes to more engineering programs or manufacturing programs. They're all moving to the cloud, so they're running somewhere that isn't locally, and you just log in and tap into that.
Perfect. So I guess a lot of that's also with the recent situation with COVID and the pandemic, working from home, working remotely, even maybe hybrid working. I'm sure a lot of businesses who were on the cloud prior to the pandemic and lockdown regulations were probably very happy that they were when it came to then accessing their business information. And because I assume some businesses could still have the machinery in the factory working remotely whilst they're sat at home, but have the know that everything's running smoothly in the office.
Yeah.
And I know you mentioned earlier using this data for predictive maintenance on machinery, so it's knowing I need to update, obviously it needs this update and this update, or it needs this software updating for it and things like that. So you can then plan better, can't you, with even when you need to go into the office to actually make those adjustments and make those updates.
Yeah, absolutely.
So if you're a small business, what type of hardware and software would you use and recommend for different uses of IT? And would you say that these are affordable for the everyday consumer?
Yeah, that's a good question. I think IoT is really accessible for a lot of companies and even individuals. And again, there's a range of hardware and software out there of different complexity levels and of course different costs. But I think especially if you're a small business starting out and just want to dip your toe into IoT, try out a few use cases, try out some proof of concept or some prototypes, then IoT hardware and software is really accessible. You think to perhaps some of the more famous maker brands like Arduinos and Raspberry Pis, which people seem to know what they are these days. And some of these small microcontroller boards cost less than a takeaway coffee. So when you think about it like that, if you want to try something, just forego your takeaway coffee for a day and buy one of these and try it out. So they're not ideal for everything, but when you want to get started, you don't have to spend a lot of money, and to really see the benefit come from IoT, getting data from something, or seeing actually how it works from end to end of getting data from one place and putting it onto some cloud software. You can do it almost for free if you wanted to, but then if you have perhaps a more complicated use case, then you need some more powerful hardware from some of the bigger manufacturers, which are more capable in a lot of ways, and especially when we come to security as well, which is really important. But there is a cost to that, but then you more kind of get what you pay for, as it were. But I don't think for a company starting out and wanting to try it, I think it really is accessible. It's one of the cheapest ways to get into Industry 4 technologies, and actually see something really quickly, and it's tangible.
Yes, definitely.
Something we haven't touched upon really with IoT is a lot of the Industry 4 revolution we're in is software based and it's on cloud and we can't see it and we're not doing this. But actually IoT is all about devices and holding things in your hand, and you have sensors and you can see them, and it's quite nice. So you can do these starter projects and go, we made that and we know how it works, and we're learning and we're teaching ourselves really useful skills, which then become useful when you have the really expensive equipment later down the line, because they all kind of work in the same way.
Yeah,
some differences, but the skills that you learn when you use the really accessible hardware and software, and there's such a great community out there as well. Likelihood is you're not going to be trying something that somebody hasn't tried before and written down and told you how to do it, and there's loads of support out there from a really good community. So yeah, I think it's a really accessible technology to get into.
Yeah, I think it's also interesting, like what you said, it's tangible. So, and also this data and the smart data, once your teams have took the data and assessed it and seen the outcomes of or maybe the answers and solutions to what the companies might have had questions about before or what they were looking for, it's quite interesting to see how this data can obviously be used for reporting or making some type of investment case. And it backs up any kind of request or communication, so it can then be used for investors or stakeholders and things like this, but also just help businesses to make better informed business decisions.
Yeah.
Like you said, you could always start small to dip your toe and see kind of how you get on with it, how easy it is, and then maybe when you get the results and actually it backs up part of your decisions, it gives you more business confidence as well. And then maybe you also then have an argument for further investment. So like you said, dip your toe in first if you like it and you see the value that comes from it, then it can always lead to more and more.
Yeah, absolutely.
So very lastly, we need to just discuss the security. So you have your sensors, which has data flying back to you, and you have all of this stored on the cloud or local VPN or system, as mentioned, and maybe using it for predictive maintenance and searching for ways to improve. But the question is, probably a lot of companies want to know is how safe is this? So hear about a lot of businesses and large corporations and organisations, even such as the NHS a few years ago, having their systems hacked and data unethically used. So how can we protect ourselves from unwanted visitors or hackers and keep this data safe?
Yeah, I mean, it's a shame that we have to talk about that in the modern world, isn't it? But, how do we keep ourselves safe online from hackers? But it's fundamental now to what we have to think about from the very beginning of a project, whether for us at the VC or for the companies that we work with and who are hopefully listening to this. It has to be your mindset from the start. And that can actually be in decision making that isn't related to technology at all. So a good way to think about it is only having data that you need, and only getting data that you need. So there's a lot of excitement that goes into IoT, and we can get data from everything. But actually, the question is, do you need it? Because if somebody ends up hacking you, in the worst case scenario, what is it that they can get their hands on? Is it sensitive? Is it really important? Is it only useful for the company? And actually, if somebody did get in and try and hack you, then actually that data is not really of any use for them. It's just how fast a machine is spinning, or something like that. And so perhaps security isn't going to be as big of a risk for you at that point. Again, in communication, do you just need to get data from a machine, or do you need to be able to control a machine back? So with some of the hacking stories that have gone on recently, and you think of the oil pipeline in America, because actually a lot of that is controlled and automated, which is a really great thing. But that's why it was a massive risk for them, because if they do get hacked, then somebody can control what they're doing. But actually, if we're just getting information for decision making and tangible insight for a company, but we can't control our equipment through the cloud, then neither can the hacker. If
Yeah,
that makes
that's a
sense.
good way of looking at it. Yeah.
So it's just about being sensible from the offset and not trying to do everything because you can, but going, what do we need? What is the risk if we lose this data? And what is the safeguard? So even from those, early decision makings, but, you've got to think about it in the devices that you are buying. Are they secure in how you're transferring data? Is it, encrypted, password protected? Are you using what you call secure communication protocols? Is where you're storing your data, is that secure and safe? And a lot of it comes down to trust. So we would put data on a massive cloud storage, but actually we're trusting that that company can look after it. So perhaps we're not directly looking after it, but we're trusting that who you're storing the data with is able to do it, and it's really reading around that and working out who is secure, who is going to protect your data the best, and trusting it. And I think because we think of it in a business sense, that becomes quite scary, but we trust these things every day when we use like banking apps on our phones, or if you use contactless payments, and things that just become second nature because we trust that the apps we're using and the phones we're using are going to protect our data. So that that definitely comes from the big manufacturers or places that equipment that you're using or cloud storage that you're using, that they need to convince you that your data is safe with them. And that's going to become a really big part of it, and it's only going to get more serious, I think, as we go on and as cybercrime gets more serious. But companies can do a lot to make sure that they are safe. Again, so just some of those things we're thinking about of picking secure hardware and software and cloud. And perhaps some companies need to bring in a new skill set that they might not have used before, of cybersecurity experts. Probably never come across them, but they're needed now, and speaking to somebody who's an expert in it and getting advice. And then, staying up to date. So I know you mentioned things like the NHS systems. A lot of that happened because computers were old and out of date and things, and it's keeping up with the current trends and rolling with it. So, if you're still using some software and the security is 10 years old, then, it's time to start thinking about moving to something newer, kind of thing. So in the same way you would your laptop or your phone or your PC. So it's something to be really wary of, but shouldn't be debilitating for companies to be so worried about it, because there's so much work and money goes into making sure these things are secure. And unfortunately, people do get hacked from time to time, but it's not everybody getting hacked every day. We hear about it because they're really big deals, but in the vast majority of cases, and a lot of the companies that perhaps we work with, aren't as at risk of that as some of the big companies that are getting hacked all over the world.
Yeah, I suppose it's a type of data, like you say, as well, isn't it? If it's your machine data, then there's probably low risk because it's not going to mean anything to anybody else. It's your team and your company. It obviously means a lot too, because it's about your productivity, accessible and highlighting to you where improvements can be made or where there's holes in your processes. So yeah, I think that's a really good point. And so just to end, where do you see IoT going in the future?
Oh wow,
very open-ended question.
That's a really open-ended question. IoT is becoming more and more commonplace in everything that we're doing. We haven't really touched upon it, but IoT, most people think of IoT in kind of the consumer sense, that we have smartphones and we have smart assistants and we have smart TVs and now we have smart fridges and smart coffee machines. And actually this kind of communication between devices and perhaps whether you call it efficiency with a smart coffee machine is up to you. But the benefits that we're supposed to see from that are almost similar to the benefits that we'll see in industry of making things either more efficient, or more accurate, if we're reducing breakdowns, if, ultimately there's no point in getting data if you're not going to do something with it. So you want to be able to get some benefit out of the data, whatever that is. Like, and we've said, there's so many, ways of doing that. But it's just going to be so natural to whatever companies buy in terms of equipment, or whatever we buy as, consumers and just general public, that everything's going to be connected. And I think that's just the way that we're heading. In some ways we're already there. Your cars are providing data to manufacturers. Smart cities are now becoming a thing, like a real thing. Smart buildings, smart factories, and what we think of now is like, wow, is we'll look in 20 years time and just go, that's normal.
Exactly. Yes,
yeah
definitely.
And everything's going to communicate, and for good or for bad. Some people might think that's a bad thing, some people probably think it's a good thing. But if I'm predicting that's where we're going, that you're going to walk into a factory and everything is connected, and you're going to walk into a house and everything is connected. But I think it's a good thing as long as it's to provide benefit at the end of the day. So I think we will.
With with commercial aspects of that, like you said, mentioned in your homes, it's very much convenience, isn't it? Like, everyone's got a Google Nest or an Alexa or whatever device it is that connects to your TV, and you can put your phone up on your TV to share photos and videos with friends all sat on the sofa, rather than sat around a 3-inch screen. You can sit and watch it on your 50-inch TV screen. So yeah, I definitely agree. I think it's consumer confidence will grow, and maybe with that, business confidence can grow. And I think you've also raised a really good point, where it's kind of like the opportunities are endless with IoT. It's what you want to use that data for, and maybe businesses starting to use it, maybe like minds will start to open to even more possibility and opportunities of wider use of IoT and data as well.
Yeah, and it's such a enabling technology. So we think about some of the other things that maybe the VC does, or in industry 4, and we think like digital twins requires IoT to get data, and we're going to see augmented reality needs IoT to get real-time data to it. Simulation driven by real world data, or automation requires IoT. So it's fundamental to a lot of the other things that we see. So it's definitely not going anywhere, and we'll see more and more of it.
Perfect. Well, thank you very, very much for your time, Thomas. Thanks for joining us today.
No problem. My pleasure.
So our next guest is Payman Shafighi from International Pheromone Systems, or better known as IPS. So welcome, Payman, and thank you very much for joining us today. Would you like to introduce yourself and IPS to our listeners?
Hi, Emma. Thank you for having me, and it's a great pleasure talking to you and to your listeners. So, my name is Payman Shafighi, and I'm the entomological scientist for IPS. IPS is a family-run business established in 1985, and we are manufacturing pheromone lures and trapping systems for monitoring pest species.
So the Virtual Engineering Centre has previously worked with IPS through the LCR 4.0 project, which was a part ERDF funded project supporting businesses within the Liverpool City region through the adoption of digital technology such as IoT. So the Virtual Engineering Centre supported IPS to learn more about these technologies such as IoT and sensors, but also to understand really the value that these technologies can bring to your company, and then also through to your clients through your products. So we obviously helped you integrate sensory and IoT technology to your bug traps that were then placed across hundreds of yards of farming land, especially through third world countries, and are used to protect crops, for example. So prior to this project, a couple of years ago, did your business use IoT technologies in any way, and what made you want to learn more about them?
Not much really, except in some production lines where we had some type of sensing technologies. For example, in our sticky trap production lines, and also in our analytical lab instruments. But we never had any sensing systems in our end products. But as an innovative company, We always look for new ways to improve current systems and processes. And also, we focus on being as environmentally friendly as possible. For example, we thought sensors will allow the end users of our products to manage and monitor a large number of traps and remotely monitor wider areas, which is a hard thing to do without having sensors and connectivity technologies.
Yeah, absolutely. I think that's a really good point as well as you might have sensors and technologies as such in your own processes and products yourself that you use on a day-to-day basis, but it might be interesting for businesses to maybe stop and think about how they could actually use these technologies within their own products that they then provide to their customers, like I said earlier, to provide added value. So what would you say were the company barriers to adopting IoT technologies?
Lack of knowledge. Lack of knowledge is, of course, the first thing. We are monitoring specialists, we monitor pests, but we have never been expert in sensing technologies. So, the first barrier for a company like us would be the lack of knowledge and how to implement these new technologies. But working with VEC enabled us to learn more and know we have internal in-house knowledge we can apply to future projects. After that, even if you gain the knowledge, you will need to be experienced enough to find the solutions for your problems in the quickest possible way. So we managed to find a number of solutions, and for us, it was finding the best one as quickly as possible. The third barrier, though, is definitely money. For SMEs, it's always difficult to invest on new things while you already have other things to be worried about, like current production lines, raw materials, staff, etc. So we always need to look for outsourced funds to cover our innovative projects and ideas. IoT and sensors are a nice thing to have at times, but we were actually surprised at how easily affordable they could be, and although they can be an investment, there are readily available technologies which can make the decisions easier.
Thanks, Payman. That's really interesting. It's also really nice to hear how some of the barriers, such as like investment and money, once you've investigated IoT a little bit further, have maybe realised it maybe wasn't as big of a barrier as what you may have firstly anticipated. So what are the main uses for the technology now within your products, and how do they support your company in decision making, for example?
So, remote access to the traps is the first thing that sensors will allow us to have. Sensors can count the number of insects trapped in each trap, identify them, and send a report to the operator saying how many insects have been trapped and if there is any further action needed to be taken by the operator, like doing any control method or anything. This intelligence is, of course, coming from miles of farming land where traps would have manually been checked, so this saves a lot of time. Sensors can also collect additional and detailed information such as weather conditions, so we can begin to investigate trends in insects and bugs' behaviors. For example, forecasting the popular time for them to visit the farmland and be better prepared, including spraying the crops for enhanced protection with as little waste as possible. So this seems like a small change, but can have a huge impact on businesses and farmers, especially those in the third world countries.
That's really exciting as well to find out as well how other data and other information is being used and how it can be used, such as, like we said, investigating the trends of insects and bug behaviour and not just identifying the popular times for solely the prevention of bugs for the crops, but also exploring more about these behaviours. So to end on, what has IPS been up to since the LCR 4.0 project, and what is the company working on in the future?
So as you know, we have recently moved to a larger site in Northwest in Cheshire based on company growth and success. Our idea of implementing sensing technologies in remote monitoring of a strategic pest of apple trees, codling moth, was successfully accepted to be funded by Innovate UK, and we are now doing feasibility studies to see how successful it can be in the field, hoping we can have the final design by February 2022 and introduce it to the market. I would also like to say that since the support received through the Virtual Engineering Center, we have gone on to collaborate with another company called Accents, who are helping us with lots of expertise in developing the sensory technologies we use, and they are actually leading the Godly Moth project. We are also working with another company originated from Cambridge University with a great knowledge of sensing technologies and connectivity, and there will be more great news about this collaboration and outcomes in the future. So this is just the beginning, and we are doing our best to introduce new technological solutions for monitoring pest species.
That's fantastic news. Thanks, Payman, and we can definitely see IPS going far in the future.
I would like to thank you so much, Emma, for making this podcast, and I would like to ask your listeners to feel free and contact me at IPS if they are interested in any type of collaboration with us, or if they would like to know more about what we are doing.
So that's all we have time for today, but thanks again to all of our listeners and of course our speakers, Thomas and Payman, for joining us today. For more information on any of the projects or case studies that were mentioned today, please check the podcast bio for more information. Thanks again, and you can listen next time on the Virtual Engineering Centre podcast, Engineering in Digital.